I am going to continue part 1 with another episode related to the where is the curvature question, because it seems that this is really hard to understand for some people. There are those who have a hard time realizing that the ball they live on is really big and they cannot, in any way, see the curvature from ground level. A very important thing to understand first is that, from our perspective, on a perfect sphere, with its own gravity, no matter where we go, we are always on the highest point. So when we look in any direction, we look down. All points around us are lower than we are, at any given time. I hope this is not very hard to understand. Considering our perspective on a sphere mentioned earlier, we would expect to have a going downhill forever feeling when moving on a sphere, right? Yes, this should be our feeling and what we see, unless the sphere is very big. In this case, the feeling and the visual perspective turn into straight moving forever. Let me explain why. Let's look at some examples of curvature and perspective, from a human being point of view, on spheres of different radiuses, and we will see how, what we perceive, changes as the radius of the sphere increases. We can see here that, on a 50 meters radius sphere, the max viewing distance is 13 meters and we are almost 2 meters higher than the most distant point. So it would be very possible to perceive the curvature, or the drop. Let's see now on a 10 kilometers radius sphere. On the 10-kilometer sphere, the maximum viewing distance is almost 200 meters, while the elevation of the person, compared to the max viewing point, is around the same value as for the 50-meter sphere. The curvature, or the drop, will be very hard to perceive. The person is the small white figure on the left. Here things get interesting. As you can see in the first image, the max viewing distance is so small compared to the actual curvature. The height is 1.86 meters but the most distant point is 2.5 km away. No way someone could perceive any drop from such a distance. Now let's see the Earth. The situation for the Earth is similar to the Moon, with the difference that the most distant point is 4.65 kilometers away, while the height difference between current point and the most distant point is 1.69 meters. To put this into perspective and have a better understanding, picture the following analogy. Take a wooden board 4.65 meters long, one of those boards used in construction. Set it down on a straight surface. Now take a grain of sand of around 1.7 millimeters in diameter and place it under one of the ends of the board. That is the curvature you want to perceive. Another analogy that I used in my previous video. Take a full frame, 16 megapixel picture of these 4.65 kilometers. So the whole distance is in one full frame. A 16 megapixel frame has 4920 by 3288 pixels. So 4920 pixels correspond to 4.65 kilometers. We can calculate that the 1.7 meters of height difference correspond to 1.8 pixels. How could you see, in such a picture, a difference of 1.8 pixels? Because that is the curvature you want to see. For smaller spheres, the visual sensation that we would have while walking on them would be that we go downhill forever, because we would see and perceive the downwards curvature. But for large spheres, due to the huge difference between height of the curvature and max viewing distance, The visual sensation transforms from downhill to straight.